Confused in class today, but I wanted to clarify something on this node voltage method. So we were looking at a system that looked something like this. We had a voltage 2, we had a resistor R, and then a voltage source 5 volts. The bottom was V1, and the question, is how do you compute the current I here? So some of you were asking, how does this relate to Kirchhoff's voltage law, where we're going around a loop, and this should give us a -5, etc. So let's just analyze it that way. So if I've got my 5, I'm going to just redraw this. That here's R and I, 5 volts, and then when we say this is V1, let's go ahead and put in let's put in a voltage source like that, V1, and then maybe this is our ground, and then up here is V2, so let's go ahead and put in a voltage source V2, okay? That means that, this point is V2, and this point would be V1. Now, if we do this in using passive sign convention, we go around the loop, we're going to have a voltage rise of V1, a voltage rise of 5, and then a voltage rise here because, the passive sign convention says we'll have a minus, the voltage here will be a minus IR, and then we'd have a plus V2. So when we write that out, we'd have a minus V1 minus 5 minus IR, and then plus V2, and that all has to equal 0. So when I solve for I, I'm going to get V2 minus V1 minus 5 divided by R. Okay, now that's one way. Another way we can do it is here's V1, and as I said in class, this point right here has to be 5 volts bigger than that point. So we can label this guy as V1 plus 5. And then that means that that I is going to be the difference between this voltage and that voltage divided by R. So it's going to be V2 minus V1 plus 5 divided by R, V1 minus V1 minus V2 minus V1 minus 5 divided by R. Okay, so we get the same answer. Now, if I let's do the other one that we were looking at in class. So in that case, we swapped the order of the resistor and the voltage source here. So we have the voltage source 5 volts. We have the resistor R. This was what do we call it? V1. And this guy, V2. So let's just redraw this guy in the way we've been thinking of looking at those. This is 5 volts. And, we have our V2, and then here would be V1. Put those together, and we can label, we don't have to label anything in terms of, I guess in that particular case, we don't have to call one of these things 0. So again, we ask the question, what is I? So that's I here. And if we go around the loop for Kirchhoff's voltage law, we're going to go minus V1. And now because it's non-passive sign convention, we'll have minus IR, minus 5, plus V2. So we would write minus V1, minus IR, minus 5, plus V2 is equal to 0. And we solve for I. It's going to be equal to V2 minus V1 minus 5 over R. Okay. Let's see, did I do that right? Okay, so then over here, again, we're going to say, what is this? We want to find out what this voltage is, because I is going to be this voltage minus that voltage divided by R. So this voltage, again, we know that this guy has to be 5 volts bigger than this. So if that's V2, this one right here has to be V2 minus 5. So that this point here is V2 minus 5 plus 5, or V2. So this point has to be V2 minus 5. And in that case, I is going to be V2 minus 5 minus V1, the difference between that and that, divided by R. So V2 minus V1 minus 5 over R. Okay, we get the same answers. Okay, hopefully that clarifies things just a little bit. It's just if we're going to use our previous tools, we need to, maybe put in representations for what V1 and V2 are.